Hello everyone, welcome to my YouTube class. In this video we will see how do we multiply two matrices. Now in order to multiply two matrices, the number of columns of the first matrix should be equal to the number of rows of the second matrix, and the resultant matrix will have the number of rows of the first matrix multiplied by the number of columns of the second matrix. That is, the order of the resultant matrix will be 2 cross 2 over here. Now how do we multiply the matrices in mathematics? We take the first row, we multiply with the corresponding elements of the first column of the second matrix and we add them. That means we say 1 into 1 plus we write 2 into 3 plus we say 3 into 5. We write 3 into 5. That means the first row is being taken, is multiplied with the elements of the corresponding elements of the first column, and they are being added. Now again we take the first row and we multiply with the second column and we write at 0, 1 in the resultant matrix. Now we say 1 into 2 plus 2 into 4 plus 3 into 6. Next, now the first row is being multiplied with the each column of the second matrix. The first row is multiplied, or I can say the 0th row is multiplied with the each and every column of the second matrix. It's done. Now the first row is being multiplied with each and every column of the second matrix. The second row is multiplied with the each column of the second matrix. The next row is multiplied with the each column of the next matrix, second matrix. That's what we will do it. Now I say 4 into 1 plus 5 into 3 plus 6 into 5. Now it is done. The first row is multiplied with the first 0th column. Now the first row should be multiplied with the first column. Now how do I multiply it? 4 into 2 plus 5 into 4 plus 6 into 6. And whatever the answer it comes, you write it. Now what is the answer that we are going to get it in the resultant matrix? Suppose if I call this as the resultant matrix. Suppose if I call this as the resultant matrix, this is matrix A, this is matrix B. Now what is it? 1 plus 6 is 7, 7 plus 15 is 22. This is 2 plus 8 is 9, 9 plus 18 is 27. 4 plus 15 is 19, 19 plus 30 is 49. 8 plus 20 is 28, 28 plus 36. 28 plus 36 is 64. Let's do it again. 8 plus 20 is 28, 28 plus 36 is 64. This will be the resultant matrix. Now let us see how do we try to multiply this and get the answer. The first and foremost thing is the number of columns of the first matrix should be equal to the number of rows of the second matrix. Then only we can do the matrix multiplication, and the resultant matrix will have 2 cross 2. Is that okay? That's very obvious thing for us. Now how do we multiply it? Now initially we take the resultant matrix. Suppose this is the resultant matrix initially, and what should be the content of the resultant matrix? It's garbage, garbage, garbage and garbage, because we did not initialize anything. Each and every element will have garbage. Each and every element will have garbage. Is that okay? Now what we need to do? We need to take each row of the matrix A. Now let us call, in matrix A there are R1 number of rows and there are C1 number of columns. And in matrix B there are R2 number of rows and there are C2 number of columns. That is what we assume it. And what is the first thing that I need to do? I need to take each row of the matrix A. Now how do I take each row of matrix A? I say for I is equal to 0, I less than R1, and I say I plus plus, and I say I plus plus. What does it will do? It will take each row of matrix A It will take each row of matrix A. Please understand this very clearly. This is very simple and important question. Each row of matrix A, it is being taken. Now next, what I need to do for each row of matrix A, I have to take each column of matrix B. Are you getting it? First you multiply 1 into 1, 2 into 3, 3 into 5. First column is done. Again you take the first row and you take the second column. 1 into 2, 2 into 4, 3 into 6. That means you have to take each column of the matrix B. And how do I take each column of the matrix B? Again, the column number starts from 0. Let me take j equal to 0. How many number of columns are there in matrix 2? That is C2 number of columns, and I say j plus plus. And what does it does? It takes each column of matrix B. Each column of matrix B. Each column of matrix B. Now after you take each row and each column of matrix B, each row of matrix A and each column of matrix B, you need to multiply and add. And how many times we are multiplying it? One time 1 into 1, 2 times 2 into 3, third time 3 into 5. Why we are multiplying 3 times? Because there are 3 number of columns or there are 3 number of rows. That is what I said. C1 should be equal to R2. There are 3 number of columns or there are 3 number of rows. That means you have to take each column of matrix A or you can take each row of matrix B. That's very obvious. Therefore, again, how I can take each row of each column of matrix A or each row of matrix B? It's very simple. I say k equal to 0. You can say k less than C1. That is the first choice. Or you can say k less than R2 because C1 should be equal to R2. We know that. And what do I write? I say k plus plus. Now what it is doing? It is multiplying 3 times. It is multiplying 4 times. It is multiplying 5 times. It is multiplication of how many number of columns? C1 columns or R2 column. Multiplication of C1 times, or you can say R2 times. You can write k less than C1 or you can write k less than R2. That's your choice. Now, what I want to do at this resultant matrix, I want to add. The basic operation is multiply, no doubt. But the multiplications are added next. But the multiplications are what? Added next. Now, if I want to add, what should be the initial value? If I say sum is equal to sum plus a of I, what should be the initial value of sum? This is addition of array. What should be the initial value of sum? It should be 0. Therefore, the complete resultant matrix, we have to initialize it to 0. The complete resultant matrix, we have to initialize it to 0 because we are going to add it. Suppose it was not initialized, how does it happen? Now, this is the resultant matrix. This is the resultant matrix. Now, at this resultant matrix, therefore, I write resultant matrix of Ij. At the resultant matrix of Ij, what we do, whatever was the previous thing, we add to it. But let it be. If you get confused, let it be. Now, what I need to do, I need to take the first row and the first column. I need to take the first row and the first column. And how many times we are multiplying here? 3 times we are multiplying here. This is the 3 times. And what represents the row of matrix A? I represents the row of matrix A. Therefore, I write here A of I. I write here A of I. Why? Because I have to take the 0th row and I represents the row of the matrix A. And now what is the first row? Can anyone say? What is the first row? 0, 0, 0, 1, 0, 2. Is that okay? The row number remains constant. The column number changes frequently. That means you have to multiply column number of times and k changes very frequently here. Therefore, it is A of Ik multiplied by. I need to multiply with what? With each column of the matrix B. Therefore, I say B of. Therefore, I say B of. What represents column of matrix B? J represents matrix of column B. Column of matrix B. J represents column of matrix B. Now, what are the columns of matrix B? If I want to write it, it is, this is the column 0, 0. Next is 1, 0. Next is 2, 0. You see here the row number changes frequently, and what changes frequently here? K, because C1 is nothing but what? R2, that is the number of rows of the matrix B. Hence I say B of JK. Hence I say B of JK. Now let us see how does it works, and we will see whatever is necessary changes we will do. If necessary changes we will do. I am going to trace it for you. Very simple code, very interesting code as well. Now the initial value of I is 0, the initial value of J is 0, and the initial value of K is 0. Now let me write here how many, what is R1? R1 is 2. What is C2? C2 is also 2. And what is C1? C1 is 3, or you can take R2, which is 3. Now 0 less than 3, yes. Now result of Ij. Now what is the value of I? 0. What is the value of J? 0. What is the value of I? 0. What is the value of K? 0, 0, 0. A of Ik into B of Jk. A of 0, 0 is 1. B of 0, 0 is 1. 1 into 1 will be returned at the result of Ij. 1 into 1 will be written at result of Ij. Now this 1 into 1 has to be added to something, right, later. Therefore, can I write this way? Therefore, can I write this way 0 plus? Can I write this way 0 plus? Hence, the previous value should be added. And how do we add the previous value? I write result of Ij plus A of Ik into B of Kj. Now the value of I is 0, J is 0. Now A of 0, 0 is 1 multiplied by B of 0, 0 is 1, and it is added to result of 0, 0, which is 0. 0 plus 1 into 1 is 1, and where you are storing result of 0, 0. Now you are storing 1. That means you got this particular value. Now you say K plus plus, the inner loop should be executed first. Now when you say K plus plus, the value of I is 0, J is 0, K becomes 1. Result of Ij 0, 0 is equal to result of 0, 0 into Ik. Ik is 1 multiplied by, it should be, it is row is changing frequently. I am sorry, it should be Kj. The row is changing frequently, it should be Kj. Now the value of K is 1 because I need to multiply 1, 0, I need not multiply 0, 1, and the value of J is 0. Now if I say result of 0, 1, now what is 0, 1? It is 2 multiplied by 1, 0. I need to multiply this 3. I was multiplying the 2. I should multiply this 3. Therefore 2 into 3. And what is the result of 0, 0? It is 1. 1 plus 2 into 3 is 7. Therefore 7 is stored over here, and you have multiplied these two things. Again you say K plus plus, the value of K becomes 2. 2 less than 3, yes. I is 0, J is 0, I is 0, J is 0. Now what is I? 0. What is the value of K? 2. What is the value of K? 2. And the value of J is still 0. Now what is the result of 0, 0? 7 plus result of 0, 2. What is result of 0, 2? 3 multiplied by result of 2, 0. Now what is the result of 2, 0? It is 5. That is what you have to multiply, 3 into 5. Now 7 plus 3 into 5 is 22. 22 will be stored, and you got this complete value. You got this complete value. This is 22. Now again you say K plus plus, K becomes 3. 3 less than 3 is false. You come out of this loop. Now after you come out of this loop, what happens? Can anyone say? After you come out of this loop, what will happen? The first result of 0, 0 is being completely done. Now after you come out of this loop, the next thing is you say J plus plus, the value of J becomes 1, and again the value of K will start from 0. 0 less than 3, yes, 0 is less than 3. Now the value of I is 0, J is 1, I is 0, J is 1, I is 0, K is 0, K is 0, J is 1. That is what I replace it. Now result of 0, 1, what is the result of 0, 1? 0 plus. Now if you did not make it as 0, it would have been garbage. A of 0, 0, again you take the first row and multiply with the second column. Now you say result of 0, 0 is 1 multiplied by, what is the result of 0, 1? Now this is result of 0, 1, you are taking the second column. It is 2. 0 plus 1 into 2 is 2. You write 2 over here. That means you got this particular answer. Now again you say k plus plus. The value of k will become 1. 1 less than 3? Yes sir, 1 is less than 3. I is 0, j is 1, I is 0, j is 1. Now the value of I is 0. The value of k is 1. The value of k is 1 and j is 1. That means you are taking a of 0, 1. Now this is a of 0, 1 with b of 1, 1. This is b of 1, 1. That is what we are going to do. Now what is the result of 1, 0? As of now it is 2 plus a of 0, 1 is 2 multiplied by b of 1, 1. And what is b of 1, 1? 4. 4 2 ja 8. 8 plus 2 is 10. Therefore, this particular value is replaced by 10. Is replaced by 10. This is the particular value. It is replaced by 10. It would be 28 now. I'm sorry. It would be 28. It is replaced by 10. Now again you say k plus plus. The value of k will become 2. 2 less than 3. Yes, 2 is less than 3. Result of ij is equal to result of ij into a of ik. The value of k is 2 into b of kj. It is 2. Now see here. 0, 2. This is 3 multiplied by 2, 1. The value of 2, 1 is 6. You say 3 into 6. Now result of ij. What is the value of result of ij? Result of 0, 0 is 0, 1 is what? 10 plus a of 0, 2. A of 0, 2 is 3 multiplied by b of 2, 1. What is b of 2, 1? It is 6. 3 6 ja 18. 18 plus 10 is 28. This value replaces to 28. That means we got this complete thing. Now again you say k plus plus. The value of k is become 3. 3 less than 3 is false. You come out of this loop. Again you say j plus plus. The value of j will become 2. That means 2 less than 2 is false. You come out. Now when you come out of this loop, what does it mean? The first row, the zeroth row is multiplied with all the columns of the matrix B. Is multiplied with all the columns of matrix B. Now after you come out of this loop, again you say I plus plus. The value of I becomes 1. 1 less than 2. Yes sir. Again the value of j starts from 0. 0 less than 2. Yes. The value of k again starts from 0. 0 less than 3. Yes sir. 0 is less than 3. Now result of ij. What is I? 1. What is j? 0 is equal to result of ij 1, 0 plus a of ik. What is I? 1 and what is k? 0. A of ik 1, 0. That means you are multiplying this 4 with the first column, this row with the first column. You see kj. What is k? 0 and what is j? It is 0. Is that okay? Now say me one thing. What is result of 1, 0? Result of 1, 0 is 0 plus a of 1, 0. What is a of 1, 0? 4 multiplied by b of 0, 0. And what is b of 0, 0? It is 1. Now you are taking second row multiplying with the first column. Now 0 plus 4 into 1 is 4. This particular value is replaced by 4 and you have got this particular answer. Now you say k plus plus. The value of k will become 2. Next time you have to multiply 5 into 3. That is what we do. I is 1, j is 0, I is 1, j is 0, I is 1, k is 1, k is 1 and the value of j is 0. Now see here. Result of 1, 0. Now what is result of 1, 0? It is 4 plus a of 1, 1 is 5 multiplied by, you have to get b of 1, 0 and you are getting b of 1, 0 which is 3. 5 into 3 is 15. 15 plus 4 is 19. You get 19 and you got this particular thing as the answer. Again you say k plus plus. The value of k will become 2. 2 less than 3. Yes, this time you have to say 6 into 5. That is what we will do. Result of ij. I is 1, j is 0, I is 1, j is 0, I is 1, k is 2, k is 2 and j is 0. And now you say me, what is result of 1, 0? Result of 1, 0 is 19 plus a of 1, 2. A of 1, 2 is 6. I have to multiply with 5. I need to get b of 2, 1 and you get b of 2, 0. I'm sorry, b of 2, 0 and here it is 6 into 5. 6 into 5 is 30. 30 plus 19 is 49. This is 49 and you get this complete answer. Now again you say k plus plus. K becomes 3. 3 less than 3 is false. You come out and when you come out, what does it mean? It means the first row is multiplied with the 0th column. Now you have to multiply the first row with the first column. You come out. Again you say j plus plus. J becomes 1. 1 less than 2. Yes. Again the value of k starts from 0. Now if the value of k starts from 0, what will happen? See here, the value of I is 1, j is 1, I is 1, j is 1, plus a of I is 1, k is 0, 1 0. Now what is 1 0? This is 4. I have to multiply it with 0 1. Now the value of k is 0 and the value of j is 1. Is it okay? See here, k is 0, j is 1. Now you say 4 into 2 is 8. Result of 1 1 is 0, plus 4 into 2, 0 plus 4 into 2 is 8. This is 8 and you got this value. Again you say k plus plus, the value of k will become 1. Wherever there is k, you write 1. Wherever there is k, you write 1. This time you will multiply 5 with 4. Now you see a result of a of 1 1 is 5, b of 1 1 is 4. Therefore, what is a of 1 1? 8 plus 5 into 4. 5 4s are 20 plus 8 is 28, and this particular thing is being multiplied. Again you say k plus plus, the value of k is 2. This time we want to multiply 6 with 6 and you get the answer. Now what is the value of k? The value of k is 2. You multiply a of 1 2 and b of 2 1, and this is 28 plus 6 into 6. 28 plus 6 into 6 is 34. You are storing 64. I'm sorry, 64. You are storing 64. You get the complete thing. Again you say k plus plus, k becomes 3. 3 less than 3 is false. You come out. It means the first row is multiplied with the first column of the matrix B. Again you say j plus plus, the value of j becomes 2. Now when the value of j becomes 2, it means I need to multiply the second column. Is there any second column over here? There is no second column. 2 less than 2 is false. You come out. That means the first row is multiplied with all the columns of the matrix B. That means you need to take the next row now. Therefore you say I plus plus, I becomes 2. 2 less than 2 is false. You come out, and at the end you see the resultant matrix. This is the way we multiply the two matrices. Okay, what we do? We take each row of matrix A, multiply with each column of matrix B, and how many times matrix multiplication has to be done? 3 times, and it is result of Ij is equal result of Ij plus A of Ik. That means you take the row and the column number changes frequently, plus into B of Kj, the row column number remains same, the row number changes frequently, and at the end resultant matrix will have the answer. And what is the order of the resultant matrix? It is R1 cross C2. What is the order of the resultant matrix? It is R1 cross C2. Please pause the video over here and make the notes, and then we will see how do we write the code for the same. Thank you. Let us see how do we write the code for the matrix multiplication. Very important question. Let's see. Now I say int main has defined row 10 column 10. You have to write the appropriate prototypes over here, whatever I am going to use the functions. Let's declare a matrix int A of row column, and we need two matrices because we want to multiply two matrices. Int B of row column. Now after I multiply these two matrices, I want to store the answer in the resultant matrix. Therefore let me say int resultant matrix result of row column Next, let us say there are R1 number of rows and C1 number of columns for matrix A, and let me say there are R2 number of rows and C2 number of columns for the matrix B. Now you have to read the matrix A. I can write here printf enter matrix A. Okay, enter order. Enter order of matrix A. Enter order of matrix A, or you can say matrix 1. And how do we read it? We say scanf %d ampersand R1 comma ampersand C1. Let me say R1 is equal to 2, C1 is equal to 3. Let me say this one. Similarly, you have to read the order of matrix B. We say printf enter order of matrix B. Enter order of matrix B. And how do you read the order of matrix B? The same way, we say scanf %d ampersand R2 comma ampersand C2. Let me say R2 is equal to 2, C2 is equal to 3. Now can you multiply these two matrices? Can you multiply these two matrices? No, because R2 is not equal to C1. Hence we may write condition here. If C1 is not equal to R2, matrix multiplication is not possible. Hence you can write printf multiplication not possible. Multiplication not possible, and we may stop the code by saying exit 0. Now if you say exit 0, you have to say hash include stdlib.h. Now assume that this is also 3 and this is 2. Now enter order of matrix A, it is I say 2 cross 3, enter of order of matrix B, I say 3 cross 2. Now what is C1 3, what is R2 3, 3 not equal 3 is false. That means matrix multiplication is possible, and if matrix multiplication is possible, I need to read matrix A, I need to read matrix B, then we have to multiply. Therefore I call the function here read matrix. Which matrix we want to read it? A. What is the order of the matrix? R1 cross C1. R1 cross C1. Now what will happen? This is matrix A in the main scope. It is of order 10 cross 10. It is of order 10 cross 10. This is matrix A. Okay. This is matrix A. Let the base address be say 1000, this is 1004, 1008 and so on up to 1036, this is 1040 and so on. What is the order? It is 2 cross 3, that means I have to read 2 rows and the 3 columns. And we want to write the read matrix function. Now how we are going to write the read matrix function? We say void, what is the function name? The function name is read matrix. What is the first parameter? It is A. A is integer 2-dimensional array, therefore I say integer 2-dimensional array. What is the second parameter? The number of rows. And what is the third parameter? The number of columns. And we want to read it. And how do we read it? We say int ij, already we know how to read the matrix. For I is 0, I is less than r, I plus plus. Here we say for j is 0, j less than c, j plus plus, and what do I write over here? Scanf percentage d ampersand a of ij, ampersand a of ij. I'll just trace it in order to understand how does this function work. Whenever you call the function, the scope of the function gets activated. This is read matrix function. There are 3 parameters. One parameter is A, next is R, next is C. Now what will happen? A is copied to A. Whenever arrays are passed, the base address gets passed, not the complete array. Next, the second parameter is R1 is copied to R. Now what is the value of R1? It is 2. That is what we have taken. R1 is 2. And C1 is copied to C. And what is C1? It is 3. Now you say I is 0, 0 less than 2, yes. J is 0, 0 less than 3, yes. Now what is ampersand of A of ij? Already I have derived the formula. It is A plus I into total number of columns plus j, and compiler multiplies with the scaling factor d. What is the value of A? It is 1000 plus the value of I is 0, and how many total number of columns are there? Here it is 10 plus the value of j is 0 into 4, it becomes 1000. It says read integer at location 1000, and suppose I say 1, 1 will be stored. Now you say j plus plus, the value of j will become 1, ampersand of a of 0 1, you just replace j with 1, it becomes 1004. Needless to say, it says read integer at 1004. This is 1004, 1008, 1044, 1048. Okay. J plus plus, the value of j will become 2, ampersand of a of 02 is 0, and it becomes 1008. It says read integer at location 1008, and if I say 3, 3 will be stored over here. Again you say j plus plus, the value of j is 3, 3 less than 3 is false. You come out of this loop Next you say I plus plus, I becomes 1, and again j starts from 0. Now wherever there is I, replace it 1, wherever there is j, replace with 0, and it becomes 1040. Read integer at location 1040. J plus plus, j becomes 1, wherever there is j you write 1, it becomes 1044. Read integer at location 1044. Similarly at 1048, j plus plus 3, 3 less than 3 is false. I plus plus 2, 2 less than 2 is false. Closing bracket of the function is taken as return. The scope dies, you come back to main and you see that the matrix A is being read. You may pause the video at this location and write the scope diagrams and the working. Now we have one more matrix. What is that one more matrix? It is a matrix B. I am not going to draw that matrix B completely. Okay, let me just take it as 3 rows and the 2 columns 0, 1, 2, 0, 1. Okay, this is matrix B if the starting address is 2000. This is 2004 and so on up to 9 and so on up to 9. This will be 2036. You do it. This is 2040. This is 2044. This will be 2080. This is 2084. We know this. I am not going to draw this completely because we know this already. How does it work? Now again we want to read the matrix. We call the function again read matrix. Same function. Which matrix we want to read it? B. What is the order of the matrix? R2 cross C2. Okay. Whenever you call the function, the scope of the function gets activated. Now this is the read matrix function. There are 3 parameters. The first parameter is A, the second parameter is R, the third parameter is C. Now B is copied to A. Now whenever the matrix are passed, the base addresses get passed, therefore it is 2000. What is the value of R2? It is 3. R2 is copied to R. What is the value of C2? It is 2. 2 is copied to 2. And we already know that ampersand of A of ij, because I am using ampersand A of ij, is equal to A plus I into number of columns plus j whole multiplied by d. Now what is the value of A here? The value of A is 2000 plus 0 I into number of columns is 10 plus j into 4. Now again if I trace it, the value of I starts from 0, the value of j starts from 0. Replace I and j with 0. 2000 plus 0 into 10 plus 0 into 4 is nothing but 2000. You do it. It says read integer at location 2000. Suppose if I say 1, 1 is done. J plus plus, the value of j will become 1. 1 less than 2, yes, 1 is less than 2. Wherever there is j, you write down 1, it becomes 2004. Read integer at location 2004. J plus plus 2, 2 less than 2 is false. You come out, again you say I plus plus, I becomes 1, j starts from 0. Now wherever there is I, you write down 1, j is 0, 1 into 10 is 10, 10 into 4 is 40, 40 plus 2000 is 2040. It says read integer here. Similarly, you trace it yourself, and after this the closing bracket of the function is taken as return. The scope dies, you come back to main and you see that the matrix B is also read. You may pause video at this point and make the appropriate notes. Please pause the video over here and make the appropriate notes and leave here some 8 lines because I need still to write multiplication of matrix, and after 8 lines you say return 0 and stop the main function. Please pause the video over here, make the notes and write down the read matrix function and draw the scope diagram. This is A, this is B, and we need to do with the resultant matrix. Please pause the video and make a notes. Thank you. Let us see how do we multiply two matrices. Now this is the resultant matrix, and resultant matrix is complete garbage. We know that the resultant matrix should not be garbage, it should be initialized to 0. Therefore, we can do compile time initialization and make it as 0. Please write down everyone, is equal 0, and when I make is compile time initialization as 0, 0, 0 is 0, and if I do not give any values during compile time initialization, the complete matrix is initialized with 0. The complete matrix is initialized with 0. Okay, now let us write one function called as multiply matrix. Let us write one function called as multiply matrix in main. Which matrix I want to multiply? Matrix A of what order? R1 cross C1. With what I want to multiply? Matrix B of what order? R2 cross C2. And where I want to store? I want to store the answer in the resultant matrix. I want to store the answer in resultant matrix. Let's say void. What is the function name? Multiply matrix. What is the first parameter? Integer 2-dimensional array, int A of row column. What is the second parameter? R1. Let me take R1 itself. What is the third parameter? C1. Let me take C1 itself. The next parameter is B. It is integer 2-dimensional array. Integer 2-dimensional array. What is the next parameter? R2 of type integer. What is the next parameter? C2 of type integer. And what is the last parameter? It is integer 2-dimensional array. It is integer 2-dimensional array. Is that okay? This becomes the prototype. This becomes the prototype. And I will just remove this because I just don't want to use these. Let me take the base address as 3000. This will be 3004. And at index 9, this will be 3036. This will be 3036. This will be 3040, 3044, and so on. And this is the resultant matrix. And already I wrote the logic to multiply. I will just write it and I will trace it line by line. I say int I, j, k, and resultant matrix is completely 0. We say for, we take each row of matrix 1. Hence we say I less than R1, I plus plus, each row of matrix 1. Then we take each column of matrix 2. J is 0, J is less than C2, J plus plus. We take each column of matrix 2. Now, after I take each row of matrix 1 and each column of matrix 2, each row should be multiplied with each column, and we do 3 multiplications because there are 3 number of columns or there are 3 number of rows. Hence, we say for k is equal to 0, k less than C1, or you can take R2 as well over here, and we say k plus plus. Now, what did I write over here? Result of ij is equal to result of ij plus a of ik. I already explained this. How do we get this? Multiplied by b of kj. Multiplied by b of kj. Multiplied by b of kj. Okay. Now, I will erase this part of the code. Already you might have written, and I will explain this, how does it works. Now, whenever you call the function, the scope of the function gets activated. Now, this is the multiply scope. How many parameters are there? 3, 3, 6 plus 1, 7. Now, this is A. Okay. Whenever arrays are passed, the base address gets passed. The base address here is 1000. The next parameter is R1, the next parameter is C1. R1 is copied to R1, C1 is copied to C1, R1 is 2, C1 is 3. The next parameter there is B. Whenever arrays are passed to the function, the base address gets passed, and the base address there is 2000, and there are the next 2 parameters R2 and C2. Now, what is the value of R2? 3, the value of C2 is 2. There is one more parameter, that is resultant. Whenever the arrays are passed, the base address gets passed, and the base address I have taken it to be 3000. I have taken it to be 3000. Is it okay? This is what happens. I hope you have written this as well. I will just remove this. I will just remove this. Okay. Now, I will trace it for one iteration. Rest all you do it. The value of I is 0. The value of j is 0. The value of k is 0. Okay, initially. And we said result of 0, 0 is equal to result of 0, 0 plus a of ik, I is 0, k is 0, multiplied by b of kj, k is 0, j is 0. Please see there. Now, what is result of 0, 0? What is result of ij? Can anyone say? in pointer notation, what is result of ij? In pointer notation, what is result of ij is equal to star result plus I into column plus j multiplied by d whole thing is equal to star. What is the value of result? It is 3000 plus what is the value of I? 0 into 10 plus 0 into 4. This is equal to star 3000. Is it clear to everyone? This is how it happens. This is equal to star 3000 plus this will be star 1000. You work out yourself. This is star 1000 multiplied by this is star 2000. This is star 2000. You work out. Now this is equal to star 3000 means go to address 3000 and fetch the value which is 0 plus star 1000. It is 1. Star 2000 is also 1. 1 into 1. This becomes 1. And where you store? Result of 0 0. And what is the result of 0 0? It is star 3000. That means you go to address 3000 and store 1. This is address 3000 and you store 1. Mind you, this is in the main scope. Mind you, this is in the main scope. Is it clear to everyone? Now you say k plus plus, the value of k becomes 1. 1 less than 3, yes. Now you say result of ij is equal to result of ij plus a of I k plus b of k j. That means a of 0 1 2 should be multiplied with 3. 2 should be multiplied with 3. In detail I have explained it already. Now result of 0 0 is 3000, result of 0 0 is 3000, a of 0 1 will be 1004. You work out, and what is b of 0 1? b of 10 will be 2040. It will be 2040. You work out, please. You do the formula and work out. What is star 3000? Star 3000 is 1 plus what is star 1004? It is 2 and star 2040 is 3. Therefore, it is 2 into 3 and it becomes 7. It says go to address 3000 and store 7. Go to address 3000 and store 7. Again you say k plus plus, the value of k becomes 2. Result of ij is equal to result of ij plus a of ik plus b of kj. Now result of 0 0 is 3000. A of 02 will be 1008, B of 20 will be 2080. Please work out. And what is star 3000? It is 7 plus what is star 1008? Result of 10 is 4, result of 20 is 5. Therefore, it becomes 2 into 5. It becomes 3 into 5. I'm very much sorry. This becomes 22. It says go to address 3000 and store 22. Mind you, it is in the main scope. Again you say k plus plus, k is 3, 3 less than 3 is false. You come out. Again you say j plus plus, j becomes 1. You know that how it works. Already I did the working. Next time what will happen? First row, zeroth row with the first column. 1 into 2 is 2, 2 plus 8 is 10, 10 plus 18 is 28. This is replaced by 28. Next time 4 into 1 is 4, 5 plus 3 is 15 plus 4 is 19, 19 plus 30 is 49 and this will be 64. This is how it works, and after this the closing bracket of the function is taken as return. The scope of this function dies and you come back to main. And after you come back to main, you have to display the resultant matrix, and for this we will write one function called as display matrix. Which matrix we want to display? Resultant matrix. Of what order? What should be the order of resultant matrix? Say me. What should be the order of resultant matrix? It is R1 cross C2. It is R1. There are R1 number of rows and there are C2 number of columns. After you display the matrix, you can say return 0 and we stop the program over here. Now let us write the function display matrix. Let us write the function display matrix. This the working of the 3 nested loops already have did it. Now we have to write the display matrix function. I say void. What is the function name? The function name is a display matrix. What is the first parameter? Result. It is integer 2-dimensional array. Hence I can say integer any matrix name. It is 2-dimensional array. What is the second parameter? R1. It is of type integer. And what is the next parameter? C. It is also of type integer. And how do we display? We say for I is 0, you have to declare two variables, I is less than R, I plus plus. I explained this in class. For j is 0, j less than C, j plus plus, and what do I write over here? Printf percentage d slash t a of ij. Don't write result of ij because it is the name is a, and after each row you have to give a new line. After each row you have to give a new line. Now how does it work? Whenever you call the function, the scope of the function gets activated. This is display. There is three parameter result, the first parameter name is a, result is copied to a. Now what is result? The base address. And what is the base address? 3000. There are two other parameters r and c. R1 is copied to r. Now what is r1? It is 2. C2 is copied to c. Now what is c2? It is also 2. Now I is 0, 0 less than 2, yes. J is 0, 0 less than 2, yes. Print a of 0, 0. Now what is a of 0, 0? Say me, what is a of 0, 0? Is equal to star a plus 0 into number of columns plus j whole multiplied by d. The value of j is 0, it is 4. Now what is the value of a? The value of a is 3000. Now it becomes star 3000. It says go to address 3000 and fetch the value 22. 22 is displayed and a tab space is given. J plus plus, j is 1. Wherever there is j, you write down 1. Column is 10. 0 into 10 plus 1 is 3004. Go to address 3004 and fetch the value. It is 28. J plus plus 2. 2 less than 2 is false. You come out. Give a new line. Again I plus plus. I becomes 1. Wherever there is I, replace it by 1. And it becomes 3040. Go to address 3040 and fetch the value. It is 49. J plus plus 1. It will be 64. J plus plus 2. 2 less than 2 is false. I plus plus 2. 2 less than 2 is false. Closing bracket of the function is taken as return. You come back to main and we have multiplied the matrix as well. This is how we multiply the two matrices, right? This, the parameter list, write down in single line. There is no space I have written here. Ijk, this is very simple. Result of ij is result of ij plus a of ik into b of kj. What does I represents? The number of rows of matrix A. What does j represents? The number of columns in the matrix B. And what does k represents? How many times you want to multiply? You want to multiply C1 number of times or R2 number of times. Thank you friends for watching this video. Please like this video, subscribe to my channel and share the channel with your friends. Thank you.